Alright, this is how I created this thing. Basically, I have my outline now of the Oringgroove, which is 246 by 235, which is the center line. Okay, and I created an arc tangent to 3 positions here. Trimmed it, mirror joined it over, deleted the rectangle. So that's kind of my outline now for, that's the center of the groove basically. Created a solid, trimmed it to the OD of the diameter, split the solid in half. Then I joined these 3 entities here on the bottom here. Create, spline, NURBS chain, these 3 guys together to a NURB spline. Okay, and that NURB spline now follows the radius. Then I created the cross section of the O-ring groove, moved it into position, and then I used the create surface swept. And what's important here is you have 1 director, 1 generator, and then you want to use normal to surface because you want the geometry to stay true in basically like a 90-degree at all times to the outside surface. So that's when you use normal to surface. And then so I create my first one, second, line outside, inside, bottom edge. Now I have 4 surfaces there. Then I mirror those guys over. Then I stitch them together. Now it's a solid. Then I offset the top and the bottom. No, first I offset the top and the bottom of the O-ring groove, so I'm a little extended beyond it. Then I created a 60 thousandths arc away for the depth of the O-ring, and then I use the OD and the ID of the O-ring basically to split that solid, top and then bottom, delete him, and then I have my tool. That's to be extracted from the solid. That's the geometry, and it should follow very nicely the the radii. It's it's very close. I think it's within the thousands or something like that. There may be a better way yet, but that's just what I came up with.